Welcome, this is your teacher David Garcia, and today we will be working with the topic of conic sections, or as they are known, conics. So let's understand what conics are. What we have here is a three-dimensional space. We have on red the x-axis, on green the y-axis, and in blue the z-axis. Now, a conic is an intersection between the surface of a cone and a plane. So let's see our cone first. There we go. This is the cone that we will be working with. And the plane that is described in here in this equation, you see, looks very similar to a line in a bidimensional plane. Our plane is in here. If you see, the plane is completely parallel, in this case to the XY plane. And by modifying the slope of that plane, we can give it like different inclinations. So let's see the intersections. So first of all, the first conic that we have is a circle. If you see the shape of the intersection here between the plane and the cone, right, it's a circle right here in the middle. Well, if we modify the height of the plane, what we are seeing is that the circle grows in its radius, and that is just because we're moving the plane up and down our three-dimensional space. Now, what happens if this plane has an inclination? Let's give it a slope, 0.5, for example. In this case, our plane is intersecting the cone as an ellipse. So this is our second conic, the ellipsis. Now, the third type, and let me put it over here, looks something like this. That is known as a parabola. In this case, you see the plane is intersecting the cone at exactly the same slope as the cone. So we can say that the plane is parallel to the sides of the cones. What we have in there is nice parabola. We continue furthering the inclination. What we have is a double intersection. And if we look at it, this double intersection on the top cone and the bottom cone, what we have is a hyperbola. So these are our 4 different conics. Now, how can we distinguish them based on their quadratic equations? Let's see a couple of examples. First of all, if we have an equation that looks like this, negative x squared plus 6x plus 3y equals 0. Okay. This equation is given to us in the form of a general conic. But how do we know what type of conic it is? Well, first of all, we have to analyze both of the variables that are in there. In this case, our x and our y. If we only have one of these variables squared and the other one isn't, automatically we will know that we are looking at a parabola. Another example, if I have negative y squared plus 10x minus 6y plus 5 equals 0, the procedure is the same. I have my y variable, and I have my x variable. And if you see, only one of them is squared. So again, automatically I know that this will be a parabola. Now, what happens when I have both of them squared? Here are the three different possible scenarios. First, I can have both of my variables squared in this way. And if both of them are positive and both of them have exactly the same coefficient, then what I'm looking at is a circle. Another variation will look something like this. 4x squared plus 4y squared minus 4y plus 59 equals 0. Again, I check my x variable and my y variable. If you see, both of them are squared. And both of them have exactly the same coefficient. Both of them have a 4. So, again, automatically, I know that this is a circle. Now, what happens when both of my variables are positive, but they have different coefficients? For example, something like this. 49x squared plus 4y squared minus 196x equals 0. Again, I check my x variable and my y variable. Both of them are squared. But now, the x has a coefficient of 49 and the y has a coefficient of 4. As they are different, automatically I will know that this is an ellipse. Another variation would be something like 4x squared plus 9y squared plus 18y minus 135 equals 0. Same procedure as before. I identify my variables. Both of them are squared, but with different coefficients. Obviously, both positive. So automatically I know that this is final variation. If I have this negative 2x squared plus y squared minus 20 equals 0. Again, the first thing we have to do is look for the variables x and y. And then I see that both of them are squared. Very good. But now, one of them will have a negative coefficient. One of them will be positive and the other one will be negative. The moment that you see this, you know that you are looking at a hyperbola. Another variation will look something like this: x squared minus y squared plus 4x plus 2y minus 6 equals 0. Exactly the same way as before, x and y. Now, if you see, we have the y with a coefficient of -1. So, in the same way as before, we automatically know that this is a hyperbola. And that's it. That's how you identify them. So let's review very quickly one more time how we do it. Worst case scenario. You identify both variables, but only one of them is squared. Whenever this happens, you automatically know you have a parabola. Scenario number 2, you have both of your variables squared, both of them are positive, and both of them have exactly the same coefficients. They are circles. Scenario number 3, both of your variables are squared, but they have different coefficients, all of them positive. Those are ellipses. Final scenario, both of your variables are squared, but one of them will have a negative coefficient. Those will be the hyperbolas. And that's it. Thank you very much, and I will see you in our next video.